Alright guys, for this lesson let's talk about something called dimensional analysis. Dimensional analysis is, well, it's just the mathematical combination of units of measure. So let's say we have 3. Without some sort of unit of measure following it, let's say centimeters, we could say, which is a measurement of length. We could say kilograms, right? We could say seconds. These units of measure that we're looking at right here, I'm going to circle them in green, right there, right? These units of measure are what give this 3 some sort of meaning, some sort of purpose, right? Otherwise, it's just an arbitrary number, and numbers are just really an abstract idea, right? They only have meaning if we assign them some sort of unit of measure. So when we talk about dimensional analysis, or if we talk about conversion factors, we're talking about the mathematical combination of the units themselves. So let's look at some practice problems real quick. I'm going to switch to blue here, and we'll do it on this side of the line over here. Okay, so we're going to say, let's see, we'll start with a simple one. I wrote down 8 centimeters multiplied by 2 centimeters squared. Okay, guys. So we can easily just ignore the centimeters and centimeters squared and just say 8 times 2 equals 16, right? But that doesn't give us any usable information like we were just talking about. So what we're going to do instead is we're going to actually ignore the numbers for a second, and let's just look at the units of measurement, okay? So we have centimeter. The operation that we're being told to do is multiply, right? And then we have centimeters squared, which centimeter squared can be rewritten or factored out as centimeter multiplied by centimeter, right? So now we have centimeter times centimeter times centimeter, right? We can put an X there if that's better for you. Just like that, right? And so we can see that that is centimeter to the power of 3, or centimeter cubed. And because it's a unit of length, centimeters are a measurement of length, right? And it's cubed, we see that it's a measurement of volume, right? That's sort of a cube, isn't it? So we have this volume measurement. But what we did was we just combined the units of measure mathematically, right? We use multiplication. And then we just do the same to the numbers. 8 times 2 in this case is 16, so we end up with 16 centimeters cubed. That is our volume. Okay? So that's one example. Oh, what did we do there? Okay, so that's one example. So we can clear this out. So now what we're going to look at is 2. We're going to do length here, meters cubed. If you wonder what I'm looking at, I just wrote down some practice problems that we could kind of go over here. 2 meters cubed, and we're going to multiply that by, what do we get? 1,500 kilograms per meter cubed. So this is, I guess we have some density here because we have volume on the bottom, right? Let's change the color real quick. Right here on the bottom, where that green arrow's pointing, we have volume, right? Because we have length taken to the power of 3, which we just talked about, right? 3 dimensions. There's one dimension, the x-axis. We have the y-axis. And then if you can imagine this line going into the screen there, that's the z-axis or z-axis, right? So, let's clear that out. So we have volume on the bottom in the denominator position, and then in the numerator position we have mass, right? And division can be said as per, right? So we have a certain amount of mass per the volume, okay, per meter cubed, okay? So let's go and clear that out, and we'll rewrite that a little cleaner. So we have, again, it was 2 meters cubed, it looks like 2 meters cubed multiplied by 1,500 kilograms per meter cubed. Okay, so we can see that 2 times 1,500 is, we can easily see that that's 3,000, right? But we're going to kind of ignore these numbers for a second. And now you don't need to slash through. I just want to make a point that we're ignoring the numbers for a second right here. Okay, and we are going to just look at the units of measurement. So let's just look at the units of measurement and the operation that we're told to perform. In this case, multiplication again. So we have meters cubed multiplied by kilograms per meter cubed. So what we want to do is we want to make this as simple as possible to combine. And we have a fraction on this side, so we could make this a fraction on this side. And the way we can do that is we can simply put it over the multiplicative identity, which is 1, right? And then we can see that we have a numerator at meters cubed and a denominator on the other side at meters cubed, because when we multiply, let's take a pause for a second, when we multiply we just go straight across, remember. We multiply the numerator times the numerator, the denominator times the denominator. We don't need to find a common denominator like we do when we add or subtract fractions. And remember, we're just using basic arithmetic here, right? So we have meters cubed on top, meters cubed on bottom. We can cross cancel right here, right? So this is now gone. Now the multiplicative identity means if we multiply something by it, it maintains its identity. So we have 3 times 1 or something like that. Or it could be 4 times 1, or it could be anything times 1 is equal that thing, right? Because what we're saying is we have 3 one time. We have 4 one time, right? When we add, the additive identity is 0. 1 is the same when we multiply, right? And we can see why right here, right? Because it's 3 one time, 4 one time, right? Keeps its identity. So the multiplicative identity of 1 right here, kilogram over 1, right, is equal to kilogram. So we can see our answer is going to be this 2 multiplied by 1,500, 3,000 kilograms, right? There's nothing super complex going on here. We're not even really needing to use algebra. We're just using basic arithmetic. Now let's talk about why we could cross cancel before we go on to the next problem, because you know I love to break it down for you so that you understand why this cross canceling bit right here worked, right? I like to make sure that you understand. So let's go ahead and clear the screen and take a look at that. So we had meters cubed over 1 multiplied by kilograms over meters cubed. Now what we did was we cross canceled here and here. Now why did we do that? Well, let's take a look at something. We'll use these same units of measure to explain the why cross canceling works. So remember, when we multiply fractions, we multiply straight across. Numerator against the numerator. So we have meters cubed, right, times kilogram. Now that's over 1 times meter cubed, right? So we agree that meters cubed over 1 is the same as meters cubed, so we were well within our rights to put that meters cubed over the 1, right? We've identified that the 1 is the multiplicative identity. So we have a few things that we've agreed upon, right, so far. So now we can say 1 times meters cubed is the same as meters cubed, right? So we can just put meters cubed on the bottom, right, instead of 1 times meters cubed. So the way we'll do that, we'll just go ahead and erase right here. Right? And let's write that. I'm going to write that a little more centered just so it looks a little better here. So we have meters cubed. So if we look at the problem right now, we see that we basically have a fraction with the same measurement or the same value in the numerator position as we do in the denominator position. Now let's just go back to basic arithmetic. If you had 3 over 3 or 4 over 4, comma there, or any number over any number, right, n over n, we know that it just equals 1 whole, right? Because 3 of 3 implies, let's see a piece of pie here, or a pie, and let's see that we have all 3 pieces, right? We have 3 of 3, right? If we had 4 of 4, right? In both cases, we have, like here we have 4 of 4, right? We have 1 whole, right? So a value over itself is equal to 1 whole, right? So we see right here, meters cubed over meters cubed is 1 whole value, right? It's equal to 1. So now we can whittle this down to 1 times kilogram, which we decided equals kilogram because it's the multiplicative identity right here, right? It's kilogram, right, 1 time, right? So we see how cross-canceling works. So we're able to just cut out all that work and just say, we're just going to cross-cancel, because we now understand why we can cross-cancel. Because ultimately what we're saying is, we're putting this up here, and we have meters cubed over meters cubed. That equals 1. 1 times kilogram is kilogram. Alright? Alright, gang, let's do one more here. We're going to do 15 grams divided by, or per, 3 grams per centimeter cubed. So we see a unit of length right here, cubed, so volume, and we see a unit of mass per that volume. So we see some density equation right there. Oops, let's put that 3 back. Okay, so we have 15 grams divided by 3 grams per centimeter cubed. It can look a little daunting at first, but we can just rewrite this, right? Because this per symbol here, that's just division. So we have 15 grams is the same as 15 grams over 1, right? It's the same thing. Divided by 3 grams over centimeter cubed. And we're going to say 1 centimeter cubed because it's assumed, right? The coefficient of 1 isn't necessary to write right there. Remember, a coefficient is what we put in front of some sort of term, right? So we have an assumed 1 there. So now we have 15 grams over 1 divided by 3 grams over centimeters cubed. Now, when we divide fractions, right, we simply flip the second fraction and then multiply. Okay, so that's what we're going to do real quick. We're going to rewrite this up here as 15 grams over 1 multiplied by centimeters cubed over 3 grams. Now, we just talked about why cross-canceling works. And right here we see we can cross-cancel. You're going to say we can't cross-cancel 15 with 3. But again, we're looking at the units, not the numbers here. We're cross-canceling this unit. Right? So now we have 15 centimeters cubed. Right? 1 times 3 is 3, so we don't need to worry about that 1, over 3. Right? So now we can combine these like terms right here. 15 divided by 3 is going to equal 5 centimeters cubed. And all we used was basic arithmetic to simplify out this particular problem and to combine the units, right? Right there. To combine the units, dimensional analysis, we simply use basic arithmetic. All right, hope that helps.